All right, this is probably more likely on the coronavirus year for this to be the way the question is formatted. Why? Because they're unlikely to give you a slope field. They might show you a slope field, but they're not going to ask you to do one, which means probably you're not going to see one, but who knows? But my guess is if you do see one, it'll be drawn out for you. You still have to interpret things. So let's take a look at this. This is a more likely scenario. It's pretty straightforward. It says you have a differential equation. You got the derivative. You got the second derivative, which is awful nice of you because you can calculate that second derivative. But they don't want you to hassle with it. And they say a particular solution of dy dx is at f(1,3). So I have a point. I have the first derivative and the second derivative. Okay. All right. I can deal with that. Okay. So write an equation for the line tangent. Okay. So here's where you might panic, but just relax. Why? Well, because how do I find equation for the line tangent? We know that equation for line tangent is going to be y equals mx plus b. So I need my derivative at the point, right, to find my slope. How do I find my slope? My slope at the point 1, 2 would be equal to, here's my derivative, right? I'm going to plug a 1 in for x. I'm going to plug a 2 in for y. And I get that my derivative is 8. Okay, that was cute and clever. But it says I want to find my line equation. Well, my point is 1, 2, right? I kind of skimmed through this a little fast. It says x equals 1. The one place where I know the point is at 1, 2. If they said at 2, I couldn't do this problem, which means they're going to tell us what the point is at the point where they want to find the line tangent, right? They have to give us the x and y values of the differential equation. Okay, so now I'm going to go plug my y value in. I plug a 2 in here. I plug a 8 in here. I plug a 1 in here, and I solve for b. And I get b must equal -6. So I get y equals 8x minus 6. And that is my part A. Part B, it says use a line equation tangent to make an approximation for 1.1. Given that f of x is greater than 0, that's going to be f double prime is greater than 0. That's interesting. I may have dropped off a really important piece of information there for you. That makes that problem much, much harder. That's got to be a second derivative, but let's take a look-see and see if I can solve this any other way. Okay, we'll talk in just a moment. We can do it without knowing that bit of information. But I suspect that bit of information was given to us so we didn't have to do what I'm about to do. This is probably an f double prime. But if it's not a double prime, we're going to go ahead and try the problem out. It says try it for 1.1. So I'm going to go y equals 8x minus 6. Plug in my 1.1. I get 8 times 1.1 minus 6. And I get the approximation be 8.8 minus 6. So 2.8. Okay. It's an over approximation or under approximation. Well, I need to know what the second derivative is, right? Because my line tangent points 1, 2. I know this. I know my slope at that point is 8, and I'm using that to approximate where it is at 1.1. If it's concave down, I'm going to miss because I'm too high. If it's concave up, I'm going to miss because I'm too low. So I just need to figure out whether I'm concave up or down. So then I panic. But I recognize between 1 and 1.1, if I go up here, now look at this. This is my second derivative, right? If I plug if I plug in any numbers, x squared is positive, y squared is positive, 3 times that's going to be positive, plus 1's positive. And then here is where it's interesting. Oh, well, I guess they don't. You don't need this. It says a y to the third. So this is what can make it negative or positive, but y to the third happens to be positive, right? So therefore, since y is positive from 1 to 1.1, since this is positive, right? That's what this says, it's positive. I misspoke about the double second derivative. We don't need that. Okay, so since it's positive in this range, then y cubed is also positive. If that's true, 1 plus 3x squared plus y squared is also always positive because they're squares, right? That has to be positive. why did I write plus? This should be just multiply y squared. Always positive. So y double prime is positive. So it's concave up. So this is going to be an under approximation. So 2.8 is an under approximation at x equals 1.1 because it's concave up. If you look at the curve would be this way, so we're going to miss because it's going to be curving up. Okay, for pick a solution of f of x with solve, find the particular solution. So now I've got the derivative. How do I turn the derivative, dy dx, into a regular equation? Aha! Well, there goes xy cubed. So I can move the y cubed to the other side. One over y, remember, separate your variables, is equal to x dx. Integrate both sides. I'm going to get, I'm going to rewrite this as y to the negative 3 so I don't make a mistake. This is 1/2 x squared plus c. So this becomes raised to the power by 1 divided by the power I get. Equals 1/2 x squared plus c. So I need to solve for y, so this is going to get tricky before it gets easier. So I'm going to put 1 over, I'm going to go ahead and multiply both sides by -2. Is that okay? You can't hear me, so I'm going to say multiply both sides by -2, so I get negative x squared. C times -2 is just c. Now, I'm going to move the y squared over here and move this down below. So I get 1 over negative x squared plus c equals y squared. Okay? And then when I got y squared, I'm going to do plus or minus the square root of 1 over x squared plus c equals y. And so that is my value. So now they want the specific solution that gives me 1, 2. So I've got to plug a 1 and a 2 in there and figure out what c is. So here we go. I've got plus or minus. I can drop the plus or minus. It's going to be positive because it has to be a positive answer when we're done. 1 over x squared. X squared is 1, so that's 1 plus c equals 2. Now I'm going to solve this monstrosity, squaring both sides. I get 1 over 1 plus c equals 4. Move that over. I get 1 equals 4 plus 4c. That's a terrible 4. I apologize. Subtract that across. I get -3 equals 4c, or c equals -3, 4. So my final equation, which I'm going to write in bright purple all the way over here on the right, I do apologize, I'm out of space, whoop, all the way over here, would be y equals the square root of, no need for a plus or minus because we already, it will not give us a positive answer, which is what we need because we're going 1, 2, is equal to, so y is equal to 1 over x squared plus -3/4 or -3/4. And I'd leave it like that and call it a day. And that's the way your answer would look. And so that's the specific solution. All right, that should be good. Just check the key and I got the wrong answer. Here's where I messed it up. Right here. So I went from -x squared to suddenly the negative is gone right there. There's needs to be a negative there. If there's a negative there, that makes this negative, which means that I would have a -1 right here, which would make this a -4, which would make this a +5, and that becomes 5/4 since, drop this pen down, this becomes 5/4 instead, not negative anymore. And so the final equation would end up looking like a negative here and a +5/4. Okay? All right, that should do it. Hopefully, I give you a little longer to look at that, and then I'm going